Okay, so next is an example of sample size for estimating the population proportion. So sample size for estimating population proportion. So let's see, we have a population, and population has two disjoint classes, A and A complement, which basically means with and without the disease. And our plan is to study to estimate the proportion of units that belong to A. So that's our plan. So what we do to find this out, we take a sample of size n and we draw it with SRS WOR, and then we use a sample proportion P. We calculate a sample proportion P and we use it to estimate the population proportion P. And we also want the margin of error in this calculation to not exceed K% at 1 minus alpha confidence limits, which means that we want to be 95% confident that the margin of error is not going to be more than K%. So if the population size is large and we ignore the fixed population correction, the FPC, then the 95% confidence interval for a proportion is going to be P minus Z half underscore PQ over N and P plus Z half under root PQ by N. This whole thing is nothing but the or at least this thing is the standard error. So which is just the sigma, and which gets you the upper limit, and which is the same thing. You get this, and we want to have the value of this. What is the value of this? This divided by sigma gives you the z value of it, and z value, so and since we want to do z half, you multiply it with this, you get the upper limit. So that's what it is. So the main important thing is how do we calculate the sigma for a specific estimator of interest. So now we know from the prior talk that z alpha by 2 underscore pq by n is equal to k, and then we can simplify this, and you will get is p q z divided by k square, where q is just 1 minus p. But here is the problem with any of these sample size calculations, that we need to have some idea of the p. Without at least some idea of the p, we cannot estimate. But what if we want it to be within two range, say P1 and P2? We want to know what sample size is, we don't know, but we can estimate that the population proportion is going to lie between P1 and P2. So then we can calculate two sample sizes. We're going to calculate one sample size P1 Q1. This remains the same, and P2 Q2 Z, and then after we calculate them, we will say that okay, we will take the larger of the two samples. So let's just do an example. We want to know the proportion of patients with a disease in the population. Okay, we expect it to be between 10 and 15%, and we stipulate that our estimate can have margin of error 3% with confidence level of 95%. So confidence level of 95% and 3%. So K is 3%, which in fraction will become 0.03, and 1 minus alpha is equal to 0.95. So Z half is going to be 1.96. Now we can just do P1 is equal to 0.10. So Q is going to be 0.Q1, and P2 is equal to 0.15. So Q2 is going to be 0.85. So N is going to be 0.10 times 0.90 times 1.96 divided by 0.03 square, that is going to be 385, or 0.1 or 0.15 times 0.85, 1.96 upon 0.03 square, that is 545. So to be more conservative, we will take the 545, which is the larger unit. But there can also be a situation when n is not large, then FPC or fixed population correction cannot be ignored. In this case, the variance of P, we have read that before, is PQ upon N, N minus N over N minus 1. Thus we see that the K is going to be Z half under root PQ upon N, N minus N upon N minus 1. And then we can simplify this, and when we simplify it, it becomes N upon N is PQ Z half square plus K square N minus 1 upon PQ Z square alpha by 2. And we can simplify this a little bit more, and then we can get N is equal to PQ Z half square upon 1 upon N PQ Z half square plus K square 1 minus 1 by N. So we need alpha, we need K, which something that we actually set, and then we need to know N, and we need to know the possible values of P to calculate N. But if we know that, we can calculate N. Now we can also have a situation that instead of proportion, we want to estimate the total number of people with the disease in the population. So what we want to do is we want to estimate the NP. If N is the total number and P is the proportion with the disease, so we want to estimate NP. So our estimator will become NP with a standard error of N PQ over N. So thus we will have the Z half N PQ over N is equal to K, and then when we simplify it, the K is going to be N square PQ Z half over K square. So this is how we calculate the sample size for this formula is what we need to calculate the sample size of a proportion. All we need, and we can do this manually, all we need is P. Z is going to be 1.96 most of the time, and we want to know the confidence or the margin of error, and you will get a sample size.